Welcome back to the channel. We're going to continue this 1973 AP Calc AB multiple choice portion of the exam. So let's dive right in. We have this limit as h goes to 0, 1 over h. ln of 2 plus h over 2 is what? Well, first intuition is let's try plugging in h as 0. Okay? If ln, let's say it's on the top, we would get what? ln of 2 over 2, when we plug in h as 0, which is ln of 1. ln of 1 is 0, so we have 0 on the top. H is 0, so that's 0 on the bottom. Okay, 0 over 0, indeterminate. So what do we do? Okay, in AB, I don't know if they teach you L'Hopital's rule. Let's assume they don't, so you have to use some other technique. So what can we do? Well, maybe the hint here is we have something divided by h. Does that look familiar to you? And h goes to 0. Maybe it's the limit definition of the derivative. Okay, so let's rewrite that over here. F prime of x is limit h goes to 0. F of x plus h minus f of x over h. That's the limit definition of the derivative, okay? So can we do that somehow here? Maybe let's break up this ln of 2 plus h over 2 by properties of logs. Instead of quotient as a single log, we can write it as a difference of two logs. ln of 2 plus h minus ln 2 over h. Okay, this looks more like this over here now. Okay, we recognize this is just f prime of 2. Okay, so what is f in this case? F is just ln x. Okay, because it's ln of 2 plus h minus ln 2 over h. That's what's happening over here, right? So f is ln x. So f prime of 2, let's find f prime. F prime is 1 over x. So f prime of 2, we just plug in x as 2. That is half. So that's choice C. Okay. Number 24, let f be cosine of arctan x. What is the range of f? So for this one, you got to be careful. Let's first do what the range of arctan is, because the range of arctan is the domain of cosine. Okay? So what's the range of arctan? Well, we know arctan, remember back in pre-calc or even algebra 2, this is between negative pi over 2 and pi over 2. Remember, the arctan is only defined in quadrants 1 and 4. Maybe that sounds familiar. So if you know how the arctan looks also, the range is from, there's asymptote at negative pi over 2, and there's another asymptote at pi over 2, horizontal asymptote, okay? So the range of arctan, once again, is from negative pi over 2 to pi over 2. Hopefully you know this from pre-calc or algebra 2, okay? So if arctan is between these, cosine is between these also, okay? So how does the cosine look from minus pi over 2 to pi over 2? It doesn't include those points, so let's be careful. It looks like this, right? With the max value of 1. That's how the cosine looks. So it's between 0 and 1, that's the range, okay? But it does not include 0, because we don't include pi over 2 and negative pi over 2, okay? So 24 is B. Includes 1, does not include 0. Okay? Integral from 0 to pi over 4, tangent squared x dx, okay? How do we solve this? I immediately see that. Well, we can change this tangent squared. Well, we know the identity. Let me write it up here. 1 plus tangent squared x is secant squared x. So tangent squared is secant squared minus 1. So we can write it as secant squared minus 1 dx. And this is easy to integrate. Antiderivative of secant squared is just tangent, okay? Antiderivative of negative 1 is just negative x. Evaluate from 0 to pi over 4. So what's tangent pi over 4? That is 1 minus x is pi over 4 minus tangent is 0 minus 0. Okay, so that's 1 minus pi over 4. 25 is B. Radius of a sphere is increasing at a uniform rate of 0.3 inches per second. This sounds like related rates, so let's keep track of what they give us, okay? Radius is increasing at 0.3 inches per second. So if radius is r, dr dt is 0.3, increasing, so positive. At the instant when the surface area becomes 100 pi square inches, so let's call surface area S, that's what they give us, is 100 pi. What is the rate of increase in cubic inches per second in the volume V? So they're asking about dV dt. What is that? So I like to write it like this, okay? And they even give us the two formulas. How helpful. How nice of them, okay? We want to find dV dt. So what is V? V, they give us 4/3 pi r cubed, okay? That's the volume of the sphere. Okay, so let's differentiate it to get dV dt. dV dt is, we use power rule here, so it becomes 4 pi r squared dr dt. We need to implicitly differentiate, okay? So we want dV dt, we have dr dt. What is r? We don't have that. So we have to use this guy, S is 100 pi. So 100 pi is 4 pi r squared. Again, that's the formula for surface area of the sphere. They give that to us. So let's solve for r. R squared is equal to 25. If I divide both sides by 4 pi, r is equal to 5. It won't be negative 5 because the radius needs to be positive. Okay, so r is 5. So now we can plug in over here. Actually, we need r squared, so we just took it from here. So 4 pi times 25 times 0.3, that's what dV dt will be. Okay, so 4 times 25 is 100, and then we have times 0.3, so that becomes 30 pi. Integral from 0 to half, 2x over square root 1 minus x squared dx. Here we can just do a substitution. Excuse me. Let's let u be 1 minus x squared. Du would be minus 2x dx. So the integral becomes, we have to change the limits of integration. When x is 0, we plug in here. U is 1 minus 0, which is 1. When x is half, u is 1 minus 1/4, which is 3/4, okay? 2x dx, that is close to here, so it will be negative du over square root of u, because that's a definition of u, okay? We can flip our limits and get rid of this negative sign. That'll be from 3/4 to 1 of du over square root u, okay? So this is a power rule. It'll be 2 square root u from 3/4 to 1. So that's 2 times 1 minus square root of 3/4 is square root 3 over 2. So that's 2 minus root 3. Okay? A point moves in a straight line so that its distance at time t from a fixed point of the line is 8t minus 3t squared. Okay? What is the total distance covered by the point between t is 1 and t is 2? Okay? Distance is this. They want the total distance covered by from t is 1 to t is 2. We need to integrate. Okay? And they even italicize total because we need to find the absolute value of this because it might change sign within this interval. Okay? So, actually, sorry, this is position. To find total distance, we integrate velocity. Sorry, that's a critical error. Because if we integrate distance, then that's not correct, okay? If we integrate a rate, then we get the distance, okay? So, the net change, basically. So, we first find the derivative of this guy, okay? So if position is this, s of t, so v of t is s prime of t, which is power rule 8 minus 6t, okay? We need to find out if the velocity changes signs, meaning if the object went from backwards to forwards, or forwards to backwards, or maybe even more times, okay? We need to know if it changed direction, or if the velocity changed sign. So let's set this guy equal to 0, 8 minus 6t is equal to 0. T is equal to 4/3 then, if we solve it, okay? So we check. Between 1 and 4/3, is the velocity positive or negative? We can plug in like 1/3, If we plug in 1/3 here, that's a positive number, because 8 minus 6 divided by 3, that's 8 minus 2, which is positive. Okay, we plug in some number between 4/3 and 2. Let's pick some number like very close to 2. We can even estimate. If it is equal to 2, then we get 8 minus 12, which is a negative number. So like 1.99999, something like that, will be a negative number. So negative, okay, so we confirm that the velocity does change sign. So we got to be careful. When we integrate the absolute value of velocity from 1 to 2, we have to break it up. This one is moving forward, so 1 to 4/3 of just the v of t, okay? But from 4/3 to 2, it's moving backwards, so we have to change the sign. It'll be negative 1 times 8 minus 6t, or it's 6t minus 8 dt, okay? So you can solve it like, you can set it up like this, okay? Here comes the tedious part. So here, this integral I solved over here. Okay, so we just do power rule 8t minus 3t squared, evaluate from 1 to 4/3. Fundamental theorem calculus, I won't go through all the steps. You get 16 over 3 minus 5. That's what I got. Okay, this integral over here, again, just do the power rule, 3t squared minus 8t, evaluate from 4/3 to 8. You notice these are almost the same, it's just negated, right? Do fundamental theorem calculus, you get negative 4 plus 16 over 3, something like that, okay? So you just add these two together. Is that what I did over here? Yeah, so you add these two together, so there's a 16 over 3 plus another 16 over 3, so I wrote 2 times 16 over 3, and then this is a minus 4, this is a minus 5, so minus 9, okay? So we simplify 32 over 3 minus 9, simplify, you get 5/3. Okay, so I won't go through all the math there. You can look at the details by pausing the video. Okay? The key here was, this is position. We differentiate to get velocity, and we saw that velocity changes sign. So we had to change the sign. We had to break up the integral and change the sign in a portion of it. Okay? Excuse me. Okay. Let f of x be absolute value, sine x minus half. The max value attained by f is what? Okay, we know sine x ranges from -1 to 1. Okay, so if we have -1 minus half, that is -3/2. Absolute value is 3/2. If it's +1, then it's 1 minus half, which is half, which is smaller than when sine x is -1. So the max value would be when this is minimized, sine x is the smallest, which is -1, minus half, so -3/2, absolute value, 3/2. Hopefully that made sense, okay? The sky, integral from 1 to 2, x minus 4 over x squared dx. This we can simply do some algebra. We divide through by the x squared, so we get 1 over x minus 4 over x squared dx. Okay. So after that, we just find the antiderivative. So this guy is just log. This guy would be power rule, so it'll be plus 4 over x. We evaluate this from 1 to 2. So it'll be ln 2 plus 2, because ln 2 plus 4 over 2 is 2, minus ln 1 plus 4, okay? ln 2 plus 2, so this ln 1 is 0, so that goes away. We have a minus 4, so 2 minus 4 is minus 2. There it is, B. This one, if log base a 2 to a is a to the 4th, then a is equal to what? This is just using properties of logs, not that hard, okay? So we can first, this is the original problem, we can first bring this power out to the front of the log. A log base a of 2 is a over 4. This a can cancel with this a, so log base a of 2 is 1/4. We exponentiate both sides by a, so it's a to the log base a of 2 is equal to a to the 1/4. So after you exponentiate and simplify, this would be 2. A to the 1/4 is the same thing as 4th root of a. Okay, so I could even write it as a to the 1/4. Okay, now we just to the fourth power on both sides. So 2 to the fourth is equal to a to the 1/4 to the fourth power. So that's equal to a. So a is equal to 2 to the fourth, which is equal to 16. Okay. Oh, this one's very easy. This is the same thing as 5 integral 1 over 1 plus x squared dx. You should recognize this as arctan. So it's 5 arctan x plus c. Suppose that f is an odd function. They even give you the definition of odd function. Suppose that f prime of x0 exists. Which of the following must necessarily be equal to f prime of negative x0? So I'm thinking you just differentiate both sides of this guy. Okay? So this guy, we would need to chain rule. It'll be f prime of negative x times negative 1 by the chain rule. This guy will just be, the negative here is just a constant, so it'll be negative f prime of x. Okay? So this is the same thing as negative f prime of negative x is equal to negative f prime of x. Okay? The negative and this negative, we can get rid of them because they're on both sides. Okay? So f prime of negative x is f prime of x. So if x is x0, f prime of x0 is f prime of negative x0. Okay, so do we have one of those? It doesn't look like we do. Maybe double check the answer. Oh, actually, sorry. We want to plug in this one. F prime of negative x0. So f prime of negative x0 would be negative x0 over here. So let me do it. F prime of negative x0. So wherever there's x, we plug in negative x0. So it'll be f prime of negative x0. So this is just f prime of x0 is f prime of negative x0. Okay? So A, that's the matching answer. Sorry about that. Okay, move on to the next page. Okay, I'll probably stop after this page for this part. Actually, we'll see, because there's only 5 problems left after this page. Okay, average value of square x on the interval 0 to 2 is, this is very easy. You just need to remember how to find the average value. That's just 1 over the length of the interval, 2 minus 0. Integral from 0 to 2, square root x dx. This is just power rule. That's easy. So half, this is from that. 2/3, x to 3/2, that's from the power rule. Evaluate from 0 to 2. Plug in the upper bound, that's... Okay, so over here, you can simplify this 2 and 2. They cancel, so it's a third. Now we plug in upper bound 2 to the 3/2 power. So 2 to the 3/2, that 2 cubed is 8. Yeah, okay, I did it right. So 2 cubed is 8. 8 to the half power is square root 8. Okay? Plug in the lower bound, that is 0. That's easy. Okay, so it's 8√3. Okay, but we don't have one of those as the answer, so we gotta probably simplify. We know that 8 is 4 times 2. So we can simplify the radical to 2√2 over 3. That's this guy. Region in the first quadrant bounded by y is secant x, x is pi over 4, and the axis is rotated about the x-axis. What is the volume solid generated? Okay, let's sketch the region. Remember how secant x looks? Hopefully you do. It looks something like this, right? Like this, and then there'll be one down here, and then another one up here, something like that, okay? But from 0 to pi over 2, remember secant is undefined at pi over 2, so there's asymptote there. It'll look something like that, okay? And we are bounded by what again? Pi over 4, so this, I drew this vertical line, and the axes, okay? So this, so I marked the region R there, okay? This is a representative radius that we're gonna use, okay? Because we know pi r squared dx, integral r squared dx, is the volume, okay? So what is r? That's where I drew this representative radius, okay? So what's the length of this r? That's just secant x. So it's secant x quantity squared or secant squared dx. Okay, from 0 to pi over 4. That's the limits of integration. Okay. This is just tangent when we integrate. So pi tangent x from 0 to pi over 4. So that's pi times, plug in pi over 4, that's 1. Plug in 0, that's 0. So that's equal to pi. If y is e to the nx power, then the nth derivative with respect to x is equal to what? Okay, so let's just start taking derivatives. If y prime is, what's y prime? N e to the nx by the chain rule. Y double prime would be n squared e to the nx. Okay? Third derivative, y triple prime, would be n cubed e to the nx. So what's the nth derivative? It'll be n to the n e to the nx. Okay? As simple as that. If dy dx is equal to 4y, and if y is 4 when x is 0, then y is equal to what? This is just solving the differential equation with the initial conditions. First order differential equation. Okay? Dy dx is 4y. Separation of variables, we move all the y's to one side, all the x's to the other. Dy over y is 4 dx. Okay? We integrate both sides now. So ln y is equal to 4x plus c. Okay? Remember the technique here. You could just plug in here, but I like to do it like this. I feel like it's easier. See, I even started doing it, but I remember, oh, I can do it this way. Okay? If we exponentiate both sides, then you get y by e. You get y is equal to e to this guy. Okay, but we can rewrite it as c e to the 4x. Remember that? Because remember, let me just do it here. E to the 4x plus c is e to the 4x times e to the c. E to the c is just another constant c. Okay, so c e to the 4x. Now we plug in this initial condition. Y is 4 is equal to c, x is 0. So e to the 0. So c is equal to 4 after we simplify. So y is 4e to the 4x. Okay? That is A. If integral from 1 to 2, f of x minus c dx is 5, where c is a constant, then integral from 1 minus c to 2 minus c, f of x dx is, I'm thinking, let's just do a substitution. So if u is x minus c, du is dx. We have to change the limits of integration though, so we plug in x as 1, we get u is 1 minus c. Plug in x as 2, you get u is 2 minus c. Okay? And then it becomes f of u du. This looks exactly like this. Just one's u, one's x, same thing. Okay? So, these two are equivalent. Okay? So it's equal to 5. Plot on the curve, the point on the curve, 2y is equal to x squared. Nearest to 4, 1 is what? I did the very similar problem on the previous year, the 1969 one. Remember, this is an optimization problem. Okay? So we want to minimize the distance from a point on this curve and this point. Okay? So we need to use the distance formula. And I did that over here. Okay, so they give us this is the curve, this is the point. Distance formula, L squared, if L is the distance, is difference in the x squared, difference in the y squared. So x minus, I use this point, 4 squared plus y minus 1 squared, okay? We can write y in terms of x. Y is just equal to x squared over 2, okay? So we can make L into equation of one variable instead of both x and y. So y, we plug in x squared over 2. Okay? Now we differentiate. 2L dl dx is equal to, here we use power rule, 2 times x minus 4 to the first power times derivative of x minus 4, which is 1. Okay, so we're left with this. Here, again, we use power rule first. 2 times x squared over 2 minus 1 to the first power times derivative inside, which is 2x divided by 2. Okay? So let's simplify. 2L dl dx is, this I left the same. This is just x, okay? And then I distributed this 2 to both terms, so it becomes x squared minus 2, okay? Further simplification, I distribute this x to both of these terms, so it becomes, and distribute this 2 to both those terms. 2x minus 8 is, 2x minus 8 plus x cubed minus 2x, okay? So let's solve for dl dx. dl dx is, we divide both sides by 2l. By the way, this 2x and this 2x will cancel. We are left with minus 8 plus x cubed on the top. We set this equal to 0 to optimize. Let's solve for x. X cubed is equal to 8. Okay, we multiply both sides by this. Then we get minus 8 plus x cubed is 0. Or x cubed is 8. X is equal to 2 then. If x is 2, we can find the y coordinate by plugging it in here. Okay, so if x is 2, then 2y is equal to 4. Or y is equal to 2. Okay, so the point 2 comma 2 is the closest point. Okay. If tangent xy is equal to x, then dy dx is equal to, here we need implicit differentiation. Okay, tangent xy is equal to x. Differentiate this guy, we need chain rule. First is secant squared of xy times derivative of the inside. We need product rule there, so it'll be first d second plus second d first. First d second, so that's x dy dx, plus second y d first, which is just 1. Okay, equal to derivative of x is 1. Differentiated both sides. Solve for dy dx. So we divide both sides by secant squared xy. 1 over secant squared xy is the same thing as cosine squared xy, okay? Oh, I did that over here, actually, okay? So on the left-hand side, we have this. On the right-hand side, we have this. So we solve for dy dx. How do we do that? Well, we subtract y, so cosine squared minus y, and then we divide by x. Okay? So that is our answer. It should be E. Okay? I guess I'll just finish the remaining 5 problems in this video. Okay? Given f of x is this piecewise function, what's this integral from -1 to 1 f of x dx? Okay? So we have to break this integral up because it's piecewise. So when it's less than 0, we integrate this curve. When it's greater than 0, we integrate this curve. So it's the integral from -1 to 0 of x plus 1 dx, and plus integral from 0 to 1 cosine pi x dx. Okay? These are both easy to solve. This is just power rule. It'll be x squared over 2 plus x, evaluate from -1 to 0. Here we need to do a little substitution. We can do it in our head though, it's easy enough. We sine pi x over pi, evaluate from 0 to 1. You do the math, it's equal to half. Okay? Calculate the approximate area in the shaded region in the figure by the trapezoidal rule, using divisions at x is 4/3 and x is 5/3. Okay? So trapezoid rule to estimate the area. Okay? So our intervals would be, they specifically said even 4/3 and 5/3. So it begins from 1 and it ends at 2. So these would be our regions, okay? 1, 2, 3, okay? Trapezoid, area of a trapezoid is average of the bases times the height. So average of, so we're in this first one, y1 plus y 4/3 divided by 2 times the height. What's the height? That is 1/3, okay? Similarly, y 4/3 plus y 5th divided by 2 times the height. That's again 1/3. And lastly, the last trapezoid, y2 plus y to the 5, y of 5/3 divided by 2 times the height again is 1/3, okay? You do all the math, I won't go over that. You get 127 over 54. Okay, so it's a tedious math problem. Okay, so the key here was just getting the regions correct. Okay, so here's 1, here's 2, here's 3. Okay, and the area of a trapezoid is average of the bases times the height. Okay, if solutions of f of x is equal to 0 are -1 and 2, then solutions of f of x over 2 equals 0 are. So if you remember, your transformations of functions is either shrinking it or expanding it, or I think in AP Pre-Calc they call dilating it or something like that. Okay, so which one is it? If you don't remember, there's an easier way to do it. Okay, instead of x is half, x is -1 and 2, you just put x over 2 is -1 and x over 2 is 2. You solve for x. So x is -2, x is 4. That's the simpler way to do it. For small values of h, the function 4th root of 16 plus h is best approximated by which of the following? Okay, So this sounds like linear approximation. Hopefully that rings a bell. So what is our function and what is our linear approximation that we're making, okay? So we probably want to use something along the lines of 4th root of 16 because h is small, okay? So we can use the 4th root of x as our function, okay? So if that is our function, 4th root of x, then f prime, because we want to find a tangent line, okay, because linear approximation is just the tangent line. Hopefully you remember that. F prime is just to the power of 1/4, x to the minus 3/4. If we evaluate at x is equal to 16 because we want to find a tangent line at x is equal to 16. Okay? You do the math, that's 1/4 times 16 to 1/4 power is 2. So 2 to the minus 3, that's 1/8. So that's 1/32. That's the slope of the tangent line at x is equal to 16. So let's find a tangent line. Y minus 2 is 1/32. That's the slope, x minus 16. By the way, when x is 16, plug in to f here, y is 2. So that's where I got this 2 from. Okay? This is a point slope form. I believe the linear approximation is you just move this 2 over. And that's the linear approximation formula. So this is what we get when we move the 2 over to the other side. Okay? So we just find y of 16 plus h, as simple as that. So when x is 16 plus h, then we're just left with h there. So it's 2 plus h over 32. Choice B. Okay. Now, final problem. If f is a continuous function on interval a to b, which of the following is necessarily true? Okay, this just says it's continuous. Let's see what the choices say. F prime exists on a to b. We don't know if it's differentiable at all. It just says it's continuous. It does not tell us that it's differentiable. Okay, so we don't know anything about differentiability. So don't get confused about, remember, if something's differentiable, it's automatically continuous. Okay? But it doesn't work the other way. If something's continuous, it's not automatically differentiable. Okay? You can think of the absolute value as a counterexample. Okay? So if this is just like zigzagging the whole time, then there's lots of points where f prime does not exist. So we eliminate that. So anything that talks about f prime, we don't know if it exists, okay? So if f of x0 is the maximum of f, then f prime of x0 is 0. Again, we don't know about differentiability. And another counterexample is if this is the max, right? But again, this point is not differentiable, okay? Limit as x goes to x0, f of x is f of limit as x goes to x0 of x for x's in this interval. This looks like the definition of continuity. So let's hold off on that. F prime of x is 0 for some, again, we don't know anything about differentiability. F prime, again, we don't know anything about differentiability. So the answer is C, okay? So the key point here is if differentiable means it's continuous, okay? Continuous does not necessarily mean differentiable, okay? That's the key here. All right, that's it for this exam. Hopefully this was helpful. Please give this video a like if it was, and please subscribe to the channel to look out for the next video, which is probably me doing the BC portion, if you're for some reason interested in that. I don't know if you're going to take BC or something, whatever. Or I'll be doing the next year, which I don't know what the year number is. Okay, so see you in that video. Bye.